November 1986. Proofhouse Range, Lithgow, New South Wales. A British engineer watches through binoculars as his rifle fires its 5,000th round. The bolt cycles. Another round chambers. The rifle keeps firing. On the table beside him, an Austrian Bullpup that's already passed the test. A Colt M16A2 that failed catastrophically 3 days ago. Parts broken, barrel life exhausted at 4,200 rounds. His rifle, stamped from sheet metal in a Sydney suburb, built for a quarter of the Colt's manufacturing cost, just keeps going. The test officer marks his clipboard. The engineer exhales. 6 months later, the Australian Army selects the Austrian rifle. The British engineer's design never fires another round for a military contract. His company folds within 7 years. Today, fewer than 5,000 of his rifles exist worldwide. The weapon that outperformed the M16 and almost nobody remembers? The Leader Dynamics T25 Malawian Quatches. This is the story of Australia's most successful failure. By 1978, the Australian Defence Force faced an identity crisis written in 7.62mm. The Lithgow L1A1 self-loading rifle, the Australian-made variant of the FNFAL, had served since 1960. In Vietnam, diggers carried it through rice paddies and rubber plantations, preferring its reliability over the early M16s that jammed beside them. American soldiers noticed. Some tried to trade. But Vietnam exposed problems the parade ground never revealed. At 9.5 pounds unloaded, the L1A1 was a beast. In jungle heat, that weight multiplied. The 7.62mm NATO round hit hard at 600 yards, perfect for European plains, excessive for triple canopy warfare where engagements happened inside 100 meters. 20-round magazines emptied fast. Carrying enough ammunition meant choosing between bullets and water. By the mid-1970s, NATO standardization was shifting toward 5.56mm. Lighter ammunition. Higher capacity. The Americans had refined the M16. The Belgians fielded the FNC. The Austrians unveiled a space-age bullpup called the Steyr August. Australia watched from the Pacific with aging infrastructure and empty pockets. Lithgow's small arms factory, built in 1912, stamped out L1A1s on machinery older than most soldiers. Replacing the entire rifle inventory would cost hundreds of millions. Buying foreign meant dependence. Building domestic meant time and expertise Australia didn't have. The Australian Army staff requirement emerged in 1981. Develop or acquire a 5.56mm rifle by 1988. Lightweight. Reliable. Accurate. Compatible with Stanag magazines. One requirement went unwritten but understood. Prove Australia could still build weapons. The 1980s rifle market offered plenty of choices. Most were terrible for Australia's unique situation. The Colt M16A2, America's refined platform. Reliable in testing. Expensive to license. Manufacturing required precision CNC machining beyond Lithgow's capability. Colt refused to transfer full manufacturing rights. Every rifle would carry American dependence in its serial number. The FNFNC, Belgian engineering, Belgian price. Excellent weapon. Zero domestic production potential. Every part imported meant every dollar exported. The Steyr August, revolutionary bullpup design from Austria. Compact. Modern. Also expensive. Also foreign. Also requiring complete retooling of Australian facilities. The tactical requirements were clear. The rifle needed to weigh under 8 pounds. Effective to 300 meters minimum. Capable of sustained fire. Resistant to dust, mud, humidity, and salt spray. Simple enough for conscripts, tough enough for commandos. Cost-effective enough to arm 70,000 soldiers without bankrupting the defense budget. The strategic requirement was simpler. Australia needed a rifle it could build. In 1978, most defense analysts would have laughed at the proposition. Australia had never designed a successful gas-operated semi-automatic rifle. The F-1 submachine gun was domestically produced but foreign designed. The Owen gun came from a soldier's home workshop, not an engineering firm. Lithgow built licensed copies brilliantly but created nothing original. Designing a modern assault rifle required expertise in metallurgy, gas systems, ammunition feeding, heat dissipation, and production engineering. It required testing facilities. It required time. Most importantly, it required someone who'd done it before. Australia didn't have that person. But Sydney did. Charles St. George arrived in Australia in the mid-1970s carrying a British passport and a resume that read like AR-18 fan fiction. Born in England, St. George had worked in British firearms manufacturing during the 1960s and early 1970s, the golden age of experimental rifle design. He'd studied the AR-18 obsessively. Where Eugene Stoner's AR-15 required expensive forgings and precise machining, the AR-18 used stamped steel and simple tools. It was the rifle designed for countries without aerospace manufacturing capabilities. The AR-18 never succeeded commercially. Sterling Armaments couldn't compete with Colt's marketing. But its operating system influenced everything from the British SA-80 to the Japanese Howa Type 89. St. George saw something others missed. The AR-18 wasn't just a rifle. It was a manufacturing philosophy. In 1978, he established Leader Dynamics in Smithfield, a western Sydney suburb better known for industrial parks than innovation. His pitch was audacious. Build a modern assault rifle using stamped components, minimal machining, and clever engineering. Make it competitive with anything NATO fielded. Sell it for half the price. The Australian military establishment was skeptical. Small arms design wasn't something you did in a suburban workshop. This was engineering normally done by Fabrique Nationale or Heckler & Koch, companies with century-long histories and government backing. St. George didn't have government backing. He had something better. He had nothing to lose. The T2 prototype emerged in 1979. Externally, it looked like someone had taken an AR-18 and simplified everything non-essential. Stamped steel upper and lower receivers. Short-stroke gas piston. 3-lug rotating bolt. Carry handle machined as part of the upper receiver. But the details revealed genius. Where the AR-18 required specialized tools, the T2 used standard commercial presses. Where other rifles needed heat treating, the T2 used phosphate coating. The bolt carrier rode on hardened steel rails that could be replaced if worn. Magazine wells accepted standard M16 magazines. No proprietary feeding systems. The entire rifle was designed around a single principle. If it could be stamped, it should be stamped. Cost per unit, estimated at $200 in 1979 dollars. Less than half the price of an M16A1. Australian Army Ordnance officers took notice. Not because they believed in St. George, but because the numbers were too good to ignore. Technical breakdown. The Leader T25 Malawian Quachas measured 38 inches overall with its fixed stock, weighing exactly 7.5 pounds unloaded. Barrel length, 16.125 inches. Cold hammer forged with 6-groove right-hand rifling at a 1-in-7-inch twist optimized for SS-109 ammunition. The upper and lower receivers were stamped from 1.5 mm sheet steel, then reinforced with welded internal structures at stress points. This was revolutionary in 1979. Most rifles still used expensive forged aluminum or machined steel. The stamping process reduced manufacturing time from hours to minutes. Each receiver started as a flat sheet, passed through progressive dies, then emerged fully formed. The operating system was pure AR-18 DNA with refinements. Gas tapped from the barrel drove a short-stroke piston positioned above the bore. The piston struck the bolt carrier, which traveled rearward against the recoil spring. A 3-lug rotating bolt locked into the barrel extension, not the receiver. This meant accuracy depended on barrel quality, not receiver tolerances. Clever detail. The bolt carrier ran on steel rails welded inside the stamped upper receiver. These rails acted as wear surfaces. When they showed erosion after 15,000 rounds, you replaced the rails, not the entire receiver. It was maintenance engineering disguised as cost-cutting. The magazine well accepted standard Stanag magazines, M16 20-rounders or 30-rounders fit without modification. This was strategic genius. Australia wouldn't need to manufacture proprietary magazines. In coalition operations, ammunition sharing was automatic. The fire control group sat in the lower receiver on a separate module. Selector positions, safe and semi-automatic only for the 5 Malawian kwaches civilian export variant. Military 3 Malawian kwaches and 4 Malawian kwaches variants offered full auto and burst modes. The trigger broke at 5.5 pounds, heavier than target rifles, lighter than military standard. Reset was positive but not match grade. Furniture was minimalist black polymer. Pistol grip angled at 25 degrees, textured for wet hand retention. Buttstock was fixed on the 5 Malawian kwaches, folding on later CC variants. The carry handle dominated the upper receiver profile, a single stamped piece welded to the receiver. Iron sights consisted of a protected front post and a flip aperture rear, 100 meters and 300 meter settings. Muzzle velocity, 3,150 feet per second with M193 ball ammunition. Effective range, 400 meters with iron sights, further with optics. Cyclic rate on full auto variants, 650 to 700 rounds per minute. The rifle fed, fired, extracted, and ejected with mechanical precision. Field stripping required no tools. Depress the takedown pins. Separate upper from lower. Remove bolt carrier and charging handle. 4 components disassembled in 15 seconds. The Leader T2 wasn't elegant. It wasn't pretty. It looked like something stamped in a Taiwanese factory, not designed by European engineers. But it worked. And it cost almost nothing to build. Now, if you're finding this interesting, consider subscribing. We're building something here for people who actually care about the details, the weapons that didn't make the history books but should have. It takes a second, costs nothing, and helps the channel grow. The Leader T2 never saw combat. Not a single round fired in anger. But it passed every test that mattered, except the political one. Australian military trials began in 1981 with early T2 prototypes. Lithgow's testing protocol was brutal. 10,000 rounds minimum, alternating between rapid fire and sustained fire. Dust exposure. Mud immersion. Drop tests from 6 feet. Salt spray for coastal operations. Temperature extremes from -10 degrees Celsius to 50 degrees Celsius. The early prototypes failed. Gas systems fouled. Extractors broke. Magazine wells cracked under repeated impacts. St. George went back to Smithfield and redesigned. Stronger extractors. Hardened gas piston. Reinforced magazine well with additional welds. The refined T25 Malawian kwaches entered formal trials in 1986 alongside the Steyr August and Colt M16A2. 3 rifles. 1 contract. The most comprehensive small arms test in Australian history. Declassified reports from those trials reveal something extraordinary. The M16A2 experienced 158 stoppages during the 10,000-round endurance test. Parts broke. The barrel showed excessive wear at 4,200 rounds, well below the 6,000-round specification. Colt engineers attributed failures to Australian ammunition variants. The Australian Army attributed failures to the rifle. The Steyr August suffered 37 stoppages, primarily magazine-related. Barrel life exceeded 10,000 rounds. Accuracy remained sub-MOA throughout testing. It passed every requirement. The Leader T25 Malawian kwaches recorded 42 stoppages across 10,000 rounds. 28 were magazine-induced, using the same M16 magazines that plagued the Steyr. 14 were extraction failures traced to ammunition quality, not rifle design. The bolt carrier showed minimal wear. The barrel maintained accuracy through the entire test cycle. In dust and mud trials, the T2 outperformed both competitors. The stamped receiver had larger internal clearances, a manufacturing limitation that became a tactical advantage. Wear-tight tolerance rifles choked on grit, the T2 shrugged. Drop tests? The T2's steel construction absorbed impacts that cracked aluminum receivers. One test rifle was dropped from a helicopter at 200 feet onto packed earth. It fired without adjustment. But the trials weren't just about performance. They were about politics. The Steyr August offered something beyond specifications. Modernity. It looked futuristic. The Bullpup configuration made it 7 inches shorter than the T2 while maintaining the same barrel length. Optics were integrated. The Austrian government offered manufacturing licenses and technology transfer. Most critically, the August had already proven itself. Austrian Army since 1977. Irish Defence Forces. Australian trials weren't a gamble. They were validation. The Leader T2 was a prototype from a suburban workshop. It performed nearly identically to the August in testing. But nearly identical wasn't enough when competing against an established platform backed by European engineering credentials. According to engineering assessments from the time, the T2 offered one massive advantage: cost. Per unit manufacturing in Australia would cost approximately $320 versus $480 for the licensed August. Over 70,000 rifles, that meant savings approaching $11 million. But procurement decisions aren't made in spreadsheets. They're made in conference rooms where risk matters more than savings. The Australian Army selected the Steyr August in 1988. It was designated the F-88 Steyr. Production began at Lithgow under license. It remains Australia's service rifle today in its enhanced EF-88 configuration. The Leader T2 received polite congratulations and no contract. The Leader T2's failure to win the Australian contract tells you everything about how military procurement actually works, and nothing about how good weapons work. Strategically, the T2 proved Australia could design competent small arms. That capability mattered. Before St. George, Australian firearms manufacturing was limited to licensed production and workshop modifications. The T2 demonstrated indigenous engineering talent existed, it just lacked institutional support. Tactically, the T2 changed nothing. No Australian soldier ever carried one in combat. No doctrine was written around it. No international military adopted it. But its influence appeared elsewhere. The AR-18 operating system, refined in the Leader T2, influenced subsequent Australian small arms thinking. When Lithgow engineers modified the F-88 Steyr into the EF-88 with improved ergonomics and modularity, they studied the T2's field stripping simplicity and stamped component philosophy. More importantly, the T2 trials demonstrated that alternative materials and manufacturing processes could meet military specifications. The next generation of rifles, Bushmaster ACR, SCAR, Bren 2, all use stamped or polymer components extensively. St. George's cost reduction engineering became industry standard 15 years after he designed it. But in 1988, that future was invisible. Leader Dynamics pivoted to civilian sales. The T25 Malawian Quachas went to gun shops in Australia and the United States as a semi-automatic sport rifle. Sales were modest. The rifle worked perfectly. It also looked like a stamped copy of something better. Australian gun owners bought F-88 style rifles or AR-15 clones. Americans bought actual AR-15s. The T2 occupied an uncomfortable middle ground, too expensive for budget buyers, too utilitarian for enthusiasts. Production and service life. Leader Dynamics manufactured the T2 series from 1978 to approximately 1983 at their Smithfield, New South Wales facility. Total production across all variants, 3 Malawian Quachas selective fire, 4 Malawian Quachas carbine, 5 Malawian Quachas semi-automatic rifle, is estimated between 2,000–3,500 units. Exact figures were never published. Cost per unit in 1980 averaged $450 retail for the semi-automatic 5 Malawian Quachas variant. That was $150 less than imported AR-15 clones, but $100 more than surplus military rifles flooding the civilian market. The manufacturing process was admirably simple. Flat steel sheets arrived from suppliers. Progressive stamping dies formed receivers in 6 operations. Welding robots reinforced stress points. Barrels came from cold hammer forging contractors. Assembly happened on a single line with minimal tooling. At peak production in 1981, optimistic about military contracts, Leader Dynamics employed 14 people and could produce approximately 50 rifles per week. That's 2,600 annual capacity. Enough for export markets. Nowhere near enough for military contracts requiring 70,000 units. When the Australian Army selected the Steyr August in 1988, Leader Dynamics was already struggling. The company folded sometime between 1982 and 1983. Exact closure date remains unclear. Small Australian manufacturers didn't make headlines when they disappeared. The tooling and remaining inventory were purchased by Australian Automatic Arms, AAA, in Tasmania. AAA redesigned the rifle slightly, removing the carry handle and adding a folding stock. They designated it the SAR, semi-automatic rifle, and SAC, semi-automatic carbine. AAA production ran from approximately 1984 to 1992. They manufactured perhaps 1,500 additional rifles. Quality was reportedly inconsistent. Early AAA rifles showed poor finishing and reliability issues. Later production improved. In 1992, the Australian government enacted strict firearms regulations following several mass shootings. The government offered AAA $2 million to close their facility and cease production, fearing civilian semi-automatic rifles would complicate new registration and buyback schemes. AAA accepted. Production ceased in April 1992. Surviving Leader T2 and AAA rifles became instant collectibles. Australia's 1996 National Firearms Agreement banned semi-automatic rifles for most civilians. Existing T2 rifles were either surrendered in government buybacks or registered under grandfathered provisions. Perhaps 300 to 500 remain in Australian private collections today. In the United States, imported Leader T25 Malawian Quachas rifles acquired pre-ban status under the 1994 federal assault weapons ban. This made them valuable to collectors. Rock Island Auction Company sold examples in 2025 for $1,700 to $2,500, remarkable for a rifle that cost $450 new. A curious postscript. In 2018, Charles St. George announced plans to resume T2 production in the United States under the company name St. George Arms. Promotional videos appeared. Websites launched. As of 2026, no rifles have shipped. It remains unclear whether St. George, now in his 70s, has the resources to fulfill that promise. The Leader T2 exists today primarily in photos, collector safes, and Australian War memorial storage. One example is held at the Lithgow Small Arms Factory Museum, displayed beside the rifles that beat it. Ask firearms historians to name significant Australian rifle designs, and you'll hear Owen Gun, L1A1 Lithgow, F88 Steyr. You won't hear Leader T2. Yet St. George's work influenced modern rifle manufacturing in ways never credited. The stamped steel receiver construction that seemed crude in 1979 became standard by the 2000s. The Bushmaster ACR, FN SCAR, CZ Bren II, all use stamped or polymer construction extensively. The AR-18 operating system that St. George refined? It powers the British SA-80, the Japanese Howa Type 89, the Singaporean SAR-21, and dozens of others. The T2 proved that short-stroke piston systems could be reliable, simple, and cheap simultaneously. But perhaps the T2's real legacy is what it revealed about military procurement. Performance matters. Cost matters. But perception matters more. The Leader T2 matched or exceeded the M16A2 in Australian trials. It cost half as much to produce. It was designed by an Australian-based engineer, built in Australian facilities, employing Australian workers. It lost to an Austrian rifle that looked more modern. That outcome taught Australian defence planners a lesson. Indigenous capability development is expensive, risky, and politically vulnerable. Licensing proven foreign designs, as Australia did with the F-88 Steyr, offered predictable outcomes and shared political risk. Since 1988, Australia has not attempted to design another indigenous service rifle. Modern military analysts looking at the declassified trial data often express surprise at the T2's performance. Dr. Ian McCullum of Forgotten Weapons noted in a 2012 interview with St. George that the T2 represented exactly the kind of thinking that should have succeeded, and exactly the kind that rarely does in military procurement. Today, Charles St. George lives in the United States. He occasionally appears at SHOT Show. He talks about stamped receivers and cost-effective manufacturing. He mentions the T2, the rifle that almost became Australia's service weapon, that performed brilliantly, that changed nothing. The Leader T2 occupies a unique position in firearms history, proof that excellence isn't enough. That engineering without institutional backing fails. That sometimes the best rifle loses. 38 inches of stamped steel. A bolt that wouldn't quit. A price tag nobody believed. This was the rifle that outshot the M16 in Australian trials. This was the rifle built in a Sydney suburb by a British engineer with AR-18 dreams. This was the rifle that proved Australia could design world-class weapons, if anyone had been watching. The Austrians had the Steyr August, modern, proven, and backed by European credibility. The Americans had the M16A2, decades of refinement and political momentum. The British expatriate in Smithfield had stamped steel and numbers that didn't matter. Australia chose the safe option. The world moved on. And Charles St. George's rifle, the one that almost changed everything, collected dust in private collections and museum corners. Sometimes the best weapon doesn't win. Sometimes it just proves the game was never about performance.